Now in this video, we will going to take up one more problem on shaft. The problem number 30. Determine the diameter of solid shaft which will transmit 300 kilowatt at 250 RPM. The maximum shear stress should not exceed 30 Newton per mm square and twist should not be more than 1 degree in a shaft length of 2 meters. Take modulus of rigidity equals 1 into 10 to the power of 5 Newton per mm square. So this has been asked in December 2019 and January 2020. So first we're going to analyze the data as he has given the transmit 300 kilowatt power. So a capital N is equal to 300 kilowatt and small n will be 250 RPM and tau max is 30 Newton per mm square and the twist. So 1 degree, so it will be pi by 180 and the shaft length L is 2 meters, which is 2 into 10 to the power of 3 mm, and capital G will be equal to 1 into 10 to the power of 5 Newton per mm square, and we need to find out the diameter of the shaft. So once you get this, now since the power is given, so the power transmitted by the shaft will be equal to capital N, which is 2 pi n into T by 60,000 kilowatt. So we know the value of capital N and small n. So you substitute those values now. 300 will be equal to 2 pi into 250 into T, capital T by 60,000. Therefore, capital T will be equal to 11,459 in 0.16 Newton meter. So the mean torque transmitted by the shaft, which is capital T, is given by 11,459.16 into 10 to the power of 3 Newton mm. So this is the one which we have calculated. So we have now converted. By default, always it will be the torque will be in Newton meter. So you convert that into mm because all other dimensions are in mm. So for the further substitution, we need to take this into 10 to the power of 3 because it is in Newton mm. Now from the strength criterion, so T by J will be equal to tau by R. So that is T is equal to JP by R into tau, that will be equal to ZP into tau. So that means substitute the values now, which is 11,459.16 into 10 to the power of 3, which will be equal to pi d cube by 16 into tau is 30 Newton per mm square. So on further simplification, we are going to get D will be equal to 124.83 mm. Therefore, the diameter of the shaft based on strength criterion will be D equals 124.83 mm. Now we will go for the rigidity criterion. So again, we have T by JP will be equal to G into theta by L. So substitute the value of torque as 11,459.16 into 10 to the power of 3 divided by pi into d to the power of 4 by 32 will be equal to 1 into 10 to the power of 5 into pi by 180 into 1 divided by 2 into 10 to the power of 3. So therefore, on cross multiplication and simplification, we have 11,459.16 into 10 to the power of 3 into 32 into 2 into 10 to the power of 3 will be equal to 1 into pi into d to the power of 4 into 1 into 10 to the power of 5 into pi into 1 by 180. So therefore, diameter of the shaft will be 107.54 mm. So adopt the permissible diameter of the solid shaft is the higher among the two values. Therefore, diameter of the solid shaft D will be equal to 124.83, which is from the strength criterion. So this is how you will be able to analyze and solve this particular problem. Thank you.